Hey guys, we made it to the final video about the half angle formulas for this lesson 10.5 multiple angle formulas. So in this lesson, we're going to discuss the half angle formulas. Once again, these are formulas that you'll be able to look up or you'll be able to be given if you were given on a test. Now, as for the half angle formulas, we will not be exploring equations. This gets a little trickier, and with this distance learning thing, let's just know how to utilize those formulas. So the first thing we're going to do, talk about the half angle sine formula. Sine of u over 2 is equal to plus or minus the square root of quantity 1 minus cosine of u all over 2. Now, remember, the goal of this is to give us more angles than what we have on the unit circle. So utilizing the angles in the unit circle, you can find more angles. So the first question we're going to do is the sine of 105 degrees. Now, with that, u is basically going to be twice as big as the angle you're given. So, for example, we're really going to find the sine of 210 over 2. If you double 105, you get 210. Now, so our u value in this case is 210 degrees. So we're going to go to our formula. Technical difficulties. Okay. So we're going to use our formula. So it'll be 1 minus the cosine of 210 degrees all over 2. Now, we didn't talk about this plus or minus. Now, the plus or minus really depends on which quadrant you're in. You typically will know what quadrant you're in, so we'll deal with the signage later. For example, with 105 degrees, if you remember that all students take calculus, we know 105 degrees would be in quadrant 2, meaning that the sign is going to be positive. That's how you just sort of get the signage out of the way. We know our answer is going to be a positive number. Now, the cosine of 210 degrees, based on your knowledge of the unit circle, and the fact that 210 degrees is in quadrant 3, which means the cosine is negative, it'll be negative radical 3 over 2. Now, if you didn't memorize what 210 degrees is, remember, when you're in quadrant 3, you do 210 minus 180 to get your reference angle of 30 degrees. Now, a reference angle of 30 degrees would lie in quadrant 1, but the cosine of 30 degrees is radical 3 over 2. So, because we're in quadrant 3, we go to negative radical 3 over 2. Now, we'll put that whole thing over 2. Now, this one's not going to become super duper nice, but we know that we have the square root of 1 plus radical 3 over 2 over 2. Now, we can combine the top here if we were to make this a fraction of 2 over 2. So you'll have 2 plus radical 3 over 2 all over 2. This is all under the square root. Now, we can simplify that fraction on the inside by doing keep, change, flip. The fun chicken thing that we do is KCF. So I would end up with 2 plus radical 3 over 4. This whole thing would be under the square root. Now, to simplify this slightly, we can just put just the top under the square root, and the bottom, the square root of 4, would give us just 2. So this is the sine of 105 degrees. Sometimes the answers work out nicer, but this one, it's still something that we can get without using our calculator. This is what we call the exact value. So let's take a look at the next problem. Now, next problem is dealing with the half angle cosine formula. The half angle cosine formula is very similar to the sine formula. Cosine of u over 2 is equal to plus or minus the square root of 1 minus cosine of u all over 2. Now, with this, you need to remember that u is going to be twice as big as the angle on the inside. So in this case, we're really looking for the cosine of 5 pi over 12. Now, 5 pi over 12 can be represented by if you were to take 5 pi over 6, which is an angle on a unit circle, put that whole thing over 2. So we're really looking for the cosine of 5 pi over 6 all over 2. A little trickier, but just remember, like the whole keep change flip thing means that you just divide the denominator by 2. So, which quadrant are we going to be in? That will tell us if we're going to have a plus or minus. So all students take calculus. 5 pi over 12 is going to be in quadrant 2. Now, in quadrant 2 is, is actually going to be in quadrant 1. Because this is really, remember, this is pi over 2. So 5 over 12 is smaller than a half, which means that we're going to be in quadrant 1, meaning that our answer is going to be positive. Now, for this, we're going to use the formula. So we know the answer is positive. Square root of 1 plus the cosine of 5 pi over 6 all over 2. Now, the angle 5 pi over 6 is actually located in quadrant 2. So we know it's going to be a negative. If we're dealing with the reference angle of pi over 6, you should remember that the cosine of pi over 6, which would be our reference angle, will be radical 3 over 2. Now this problem is going to look very similar to the one that we just did in the last example. So what we do is we're going to have sorry, my computer's acting up. 1 minus radical 3 over 2 all over 2. Then we have 2 minus radical 3 all over 2 all over 2. Sorry about that weird pause. Basically, remember, this is really 2 over 2, so 2 minus radical 3 all over 2, and then the bottom has a 2. We're going to put this over 1, keep change flip, and you end up with the square root of 2 minus radical 3 all over 4, and the square root of 4 would be 2, so the bottom is going to be 2, but the top will be 2 minus radical 3 all under the radical sign all over 2. Okay. Now, let's look at our last half angle formula dealing with the tangent. Now, this one's sort of a bit ugly looking. The tangent of u over 2 is equal to 1 minus the cosine of u all over the sine of u. It could also be written as the sine of u all over 1 plus cosine of u. It doesn't really matter. We'll be able to simplify either way. Please note there is not a plus or minus, nor is there a radical in this case. So these answers come out to be a little bit nicer. The tangent of 7 pi over 8 can be represented, remember, if we double this angle, meaning just divide the denominator by 2, we end up with 7 pi over 4 all over 2. And we're going to look for the tangent of this angle. That means that u in this case would be 7 pi over 4. Now, if we go to our formula, we're going to do 1 minus the cosine of 7 pi over 4 all over sine of 7 pi over 4. Notice I'm just going to use the one on the left side. Doesn't really matter which one you use. In this case, we are going to remember what the cosine of 7 pi over 4 is. You need to remember which quadrant we're dealing with. So remember, all students take calculus. Okay. In this case, 7 pi over 4 would be an angle located in quadrant 4. Okay. Now, if we're dealing with quadrant 4 angle, what we're going to do is we know that cosine is going to be positive and sine will be negative. So you have 1 minus the cosine of pi over 4 would be radical 2 over 2. And the bottom would become negative radical 2 over 2 because the sine in quadrant 4 is negative. So in this case, we can simplify this slightly. This is really, remember, 2 over 2. So it'll be 2 minus radical 2 over 2, all over negative radical 2 over 2. And if we keep change flip, we get negative 2 over radical 2, meaning I'm going to end up with, as I distribute that negative 2 across, I get negative 4 plus 2 radical 2 over 2. Sorry, radical 2. So sorry, 2 radical 2. Now, I just realized you could have just canceled out the 2 there and just been left with just 2 minus, oh sorry, negative 2 plus radical 2 over radical 2. In this case, we could simplify the 2's first, so I can get rid of the 2's now. So I end up with what I should have realized we were going to get. Now, just like any good cheerleading squad, we don't want the crazy person on the bottom of the pyramid, just like we don't want the crazy person in the crazy number in the bottom of the denominator, bottom of the fraction. So we'll multiply both the top and the bottom by radical 2. So I end up with negative 2 radical 2 plus 2 all over 2. Oh, and look at that. We can simplify the 2's a little bit, meaning I'm going to end up with negative radical 2 plus 1. Now, all that algebraic manipulation, just make sure that you can get the simplest form when asked. Now, just so that we can sort of do a little bit of a conclusion right now, I just want to show you a different type of question. If you're given that theta is in this triangle and we want to find the sine of 2 times theta and the cosine of theta over 2, I want you to be able to sort of do these type of problems. I think there's a couple of the problems I want you to do for homework. Now, what we have here is we have theta. Now, what we can do is we can figure out what the sine of theta is, the cosine of theta, as well as the tangent, but we don't really need it that much. But why not? We can find it. Sometimes you're told what quadrant you're dealing with, but just because we're dealing with a triangle, we're going to assume all sine, cosine, and tangent are positive answers. So in this case, we have the hypotenuse located here, the opposite here. To find the adjacent, we're going to use our favorite Pythagorean theorem. So 5 squared plus x squared equals 13 squared. If you knew your triples, you would know right away that x is 12. Because 5, 12, 13 is a Pythagorean triple. So with this, we can find the sine. The sine is going to be 5 over 13. The cosine is going to be 12 over 13. And tangent will be 5 over 12. So now we're going to find the sine of 2 theta. To find that, you're going to first translate this formula using the double angle formula we talked about at the beginning. So this is really 2 times the sine of theta times the cosine of theta. Now, in this case, I know the sine of theta is 5 over 13. The cosine of theta is 12 over 13. Now, in this case, we can multiply them across. So I get 2 times 5 times 12 would give me 120. 13 times 13 gives me 169. And we're done. Now, the cosine of theta over 2, that's going to be using that formula with the square root. So it's going to be the square root of 1 plus cosine of theta all over 2. Once again, we're assuming that the angle is going to be positive, so we don't have to worry about that positive negative thing. Sorry, the cosine is positive. So now we have 1 plus the cosine of theta, 1 plus 12 over 13, all over 2. So 25 over 13 all over 2. And so now we'll put that over 1, keep, change, flip. So we'll keep, change, flip it. 1 over 2. So you get 25 over 26. You could simplify this slightly. The square root of 25, for example, would be 5. So I'm just going to go in this direction now. So you get 5 over radical 26. We don't want to have that radical on the bottom, so we'll just multiply the top and the bottom by radical 26. So you get 5 radical 26. Sorry, my pen does not want to cooperate right now. Why are you not writing? It does not want to write right there. 26. There you go. I feel like we're back in the classroom, guys, especially 7th period. So your final answer would be 5 radical 26 over 26. Now, I did give you guys some homework questions, so feel free to look through the videos and everything. But if you have any questions, feel free to make a comment or email me, and we can talk about there. Okay, thanks, guys. Have fun. Bye.